What's today's date? It is 26th 11 2021. Fine. So what are we looking at now? We are looking at object-oriented programming. Now you might be thinking now, we are not studying Java, right? Object-oriented programming. Okay. So if you remember one thing now, whenever we talk about OOP, what comes to our mind? What comes to our mind, guys? I'm looking at the chat box right away. Just tell me what comes to your mind when you hear of object-oriented programming. Let's have some background of OOP. Now, please don't say, sir, I don't know programming, okay? Please don't say I don't know programming. Just say something. No answer is no right and wrong answer here, right? What is the background? What actually led to this? Okay, so I'll give you a little hint. So I will go online and just show you something here. And this actually happened to me when I studied computer science. I mean, when I was doing my BSc. Now, if you see here, I'm going to type this. Has any of you heard of this language called BASIC? If you've heard of it, just type I, BASIC. Are they showing me some other things? Have you heard of this language called BASIC? BASIC. Yes, classes, AMA, good. If you Google BASIC, now you're going to get what? Some dictionary meaning. That's not what I wanted. If you don't know, did you see here? Did you see here, guys? Look here, high-level programming language. But many of you, I'm pretty sure many of you may not have heard of that. Developed by John Kenemy and Thomas E. Coates. Actually, in that Dartmouth conference, actually, this was in 1964, they developed this, but it was in 1957 that they coined the word artificial intelligence. I'm pretty sure it is John G. Kenemy and something Thomas Coates, I think, or John G. Kenemy, I think, and another person, when they coined the word artificial intelligence at that Dartmouth conference in I think in UK or somewhere, I don't know where it is. So if you've not heard of this language is so funny. So we have another thing which we call QBasic, which stands for Quick Beginners All-Purpose Symbolic Instruction Code, developed by Microsoft. Okay. So I'll tell you the reason why QuickBasic. Okay. So Quick Beginners All-Purpose Symbolic Instruction Code. So you see something like this. Have you worked on Turbo C compiler? Okay, fine. Okay, Akira, no problem. Don't worry. So I'll tell you why I'm telling about this, okay? Though we say this is high-level language, it's not object-oriented actually. So let me take example from Geek4Geeks. Maybe they have written something about Quick Basic, okay? An acronym for Quick Beginners All-Purpose Symbolic Instruction Code. It is developed and launched by Microsoft in 1991 and is, I don't think so. 1991, I think it is earlier than that actually, and considered to be one of the most ideal languages for what? Absolute beginners. But see the funny part, who uses Quick Basic now? I mean, literally no, but no company uses it. Rather, they start you with what? C. Now you see the reason why you have to use C. And see the funny part here, please look here. No concept of type here, print, hello geeks, print age. No concept of type, no concept of stuff. Why am I telling you this now? It's similar to my what? Python. Clear screen, CLS, start typing some blah, blah, blah. Now, the problem here is there is no object orientation. Now, what do I mean by this? Every time, say you created a program. So there's a case study here, and that should actually happen to me. So I'll start from my final year project. So case study. Background translates to what? Case study. The stuff was to design, I want to design kind of an IDE, okay, that will be able to solve differential equations. So let me not call it IDE now, let me call it a program. Design a program to solve differential equations. So mathematics students, you will understand. So you might think, okay, fine, please feel free to Google this, okay? Differential equations of first order, second order, third order, fine. Now you notice one thing, that anytime you want to add some methods to this, or you want to kind of add some methods or functions or whatever, you see the program will break. Again, it uses the concept of interpreter, so there is no compilation in QBasic. Now, this is happening actually because there is no orientation, OOP. They call OOPS concept. There is no orientation in this case. If that is the case, how can we make this program intelligent, right? Now, I'm not saying you should have artificial intelligence, no. Let the program mimic what we feel like. I mean, we want it to do. We want the program to look like a real program that should not break out when I want to do little modifications. That is the background behind object orientation. Now, what does object orientation do? So let's take again help from Google and say, what are the pillars of OOP now? So since this holds true, I'm going to say, okay, Google, what do you mean by object oriented? Oh, is there object oriented programming? What is this actually? And we look at the pillars of OOP. So this is a paradigm, right? That is based on the concepts of objects. Do you know that in Python, everything is an object? Yes or no? Your strings, your integer types, your whatever you call it, all are objects only. So which can contain data and code. Data in the form of fields are known as attributes or properties, and code in terms of users are known as methods. So no worries. So let's look at pillars of OOP then. You have your encapsulation, you have your inheritance, you have your polymorphism, you have your what. So let's look at it, pillars of object orientation. Abstraction, encapsulation, inheritance, and polymorphism. So we try to look at two of them now, encapsulation and inheritance. So what is encapsulation? So you should do what now? Gulu gulu. Fine. 4 pillars. So when you look at this, okay, they say 5 pillars. 5 pillars is data hiding. Fine. Take care. So what is encapsulation? We better show that with an example. Okay. What is inheritance? We also explain that with an example. Now you got the concept. You know what object orientation is. You know the 4 pillars of object orientation. You know why we need object orientation. Fine. Now let's proceed. So this is fine. So based on that now, we come across, OOP was, the foundation of OOP was laid. So let's look at our problem statement now, which is what? Object orientation in Python. In what? Python. So what do we know? Some hints, some notes. We know that Python is an object-oriented language. We agreed, because everything in Python is an object. Is an object in Python. If it's an object, that means that this object consists of what? 2 things, right? So consisting of 2 things now. What are those things? 2 things. Sir, why are you calling them things? Actually, what should I call them then? So they are called 2 things. What are they? Data and what? Functions. Right? So functions, remember I used to use this interchangeably. Functions are also known as what? Methods. Agreed. When I say print function, at times I say it's a print method. No worries. Now, this function obviously would work on data. Yes or no? Fine. If that is the case, excuse me, sorry, I'm getting hiccups. Sorry, guys. If that is the case, that means that these methods implement what? Implement what? Other methods that are inside them, right? Okay, sir, why are you repeating yourself? So what are these methods now? That means that in Python also methods such as this exist. We have seen them. We have used them actually. Yes or no? Replace we have seen. Upper we have seen. Remember is a method. Fine. Lower we have seen, etc. Split. And then what's the opposite of split? We saw that always. Okay. In list. Split opposite is what? Join. We've seen all these methods. Fine. If that is the case now, let's look at one thing now. Okay. If we say, we have said the concepts of object, and Amar said something classes. So I want to connect these dots. How is an object different from a class? Next question. Okay. How do you differentiate an object from a class? So that will lead us to what? What is a class? I'm looking at the chat box now. What is a class? Can we say a class is an object? Can we say a class is an object? Yes or no? All right. So I believe some of you have programmed, right? So we can say a class is what? An object template, right? See, correct me if I'm wrong, guys. Okay? It's a template for what? An object. Fine. If you develop applications, you must have come across something like frameworks. Example, I want to develop a shopping cart. Shopping cart. Who has developed a shopping cart from scratch before? Type I. Sir, what is this now? You are confusing us. I hope I'm not confusing you guys. What do you mean by a template? A template means it is a kind of error. I don't want to say a wrapper class. It's kind of an implementation, right? That shows you how maybe the real world object will look like. Yes or no? So a shopping cart application you are developing, you might use what? Templates, such as what? WordPress. That means if you're going to use WordPress, WordPress is a template. Yes, objects are instance of a class is fine. Can we say now a class is a template for an object? Good boy. Fine. So we use WordPress now as a template to create these shopping carts, meaning I can use this and start instead of me going and reinventing the wheel. No worries. So how do we create classes in Python? Next question. How do we create classes in Python? How are classes created in Python? Okay, we know how functions are created in Python. Yes or no? Functions are created using the def keyword. Agreed? So classes will be created, using the what? Class keyword. And by default, we should remember that the class name should start with a capital letter. Now, if you are going to have words like this, so okay, how are classes created? Answer, using keyword class, followed by class name. I'm using the capital letter now, class. If it is combination of words, you can use this. Or you use this. If it is two-letter words, you can use small like this and then name. But this is good when you are working on variables by convention. But if you're working on class, always start it with class name and use camel case. This is now camel case, right? Where each of the beginning of the word you should be capitalized. Fine. So example now, let's create a class, okay? And then we try to explain what this class will do. Remember now, if you have for example, we want to say add two numbers and return the sum. Add two numbers and return and print the sum. Obviously, sum is addition of number, right? And print the result. So let me not repeat myself and print the result. So what will you do? You can just ask the user to enter, right? You can also use a function. Yes or no? So if I were you, please listen, guys. If I were you, I will write this in various ways. This is how we learn. Please listen. There are various approaches, yes or no, to write this program. First one, I can say num1 equal input, you know what I'm talking about, and I need to convert it to int, typecast to int input, say enter whatever. Okay guys, enter blah blah blah. This is done. Then repeat the same thing again, store it in num2. This is the old way we have been writing program. Yes or no? Int input blah blah blah, enter num2. Then what I did was what? Num3 equal what? Num1 plus what? Num2. You can actually wrap this around print statement and it will print that. This is first case. Second case, you use function. You say def. So if you're going to use function, you have to say def, def, maybe you call it add. Please check whether this is a keyword. I think add is a keyword. Either add or sum is I'm pretty sure sum is a keyword. To avoid this, call it addition. Open this and that. Write whatever is inside. Done. The third one now, even you can also use no need of recursion here. The third one now is using the concepts of objects. So using classes. So this is our interest. Using classes. Guys, I hope you're able to follow, right? So using classes now, let's start. Class. What's the name? We call it addition. Colon. Okay, it's similar to my function. Please, sorry, this is not semicolon, this is colon. Okay, so it's similar to my function. And by the way, I told you guys that you don't even need semicolon in Python. Okay, just try to do this with semicolon and also try running the same thing without semicolon. Okay, guys. Now, if this holds true, there is something here I'm going to write, and then we have to look at each of them. Since you're using the concept of OOP, please pay attention. We're going to write next thing now. So this is done. I will now say, okay, fine. What I try to use, okay, let me not be wasting time by writing most of them. Dash, like underscore. There is this method called init method. I'm going to explain to you this, okay? And it takes an argument. What is this self? You get it now. And then I say, okay, fine. I needed number 1, number 2. Okay, here I'm going to call it A, comma B. No doubt. Now I will say inside, please pay attention to indentation. Here I'm going to get an error now. Okay, you have to push this further. I said use tab class. Okay, so this is a different level. That is a different level. Now another one will be inside here. Maybe I'll start from here. I'll say self dot A is equal to A, then self dot B is equal to B. I will explain, don't worry. Now I have a method which I call def add. Okay, this is addition is the class name. Now the method I'm going to call is def add, which takes this as an argument, self as an argument. Don't worry, we will look at this and return the what? Addition of both. Instead of saying A plus B now, I will now say return self dot A plus self dot B. Now I have to create an maybe object for this. Okay, I will now say maybe like I say C is equal to addition is in the class name. Okay, then I will pass maybe like 3, 2 inside. I'll now say print. We run this. Print maybe C dot add. No worries. Done. What it will print as output? Output will be 5. Now let's understand each and everything here. So you have come across so many things now, right? So what are the new terms we have come across? We call it jargon busting. Sometimes they call jargon busting, sometimes they call keywords explanation, sometimes they call anything is fine. So here, let's understand one thing here. One is called a double underscore init. Okay, another one is called self. I think these are the two things we came across now, right? Maybe you've seen class, so class is done. Fine. Now, what you should remember is, yes, we use this class to create a class, to create the class in Python. No doubt we need the keyword. And that class name usually start with what? Capital letter. Done? Now, virtually most of the classes, and you're going to see it when we start building the game application now, most of the classes we start with this init method. So what is this init method? Can we call it any other thing? Now, and please listen. Can I actually write this as init like this? init, maybe 1 underscore, or can I write it as ordinary init? Now, why is it written as with double underscore is that, please listen, it indicates that this is a special kind of method. Is a method, yes or no? How do you know it's a method? In closing braces. It's a special kind of method, okay? And it is called what? Do you remember? It's called a constructor. We came across constructors when we looked at sets. Yes or no? Fine. So it's a constructor and it's automatically called whenever we create a new object from our class. So it's like the way we use constructor, right? Fine. So this is the same way also we are going to use this. So this init method is a special type of method called as what? A constructor. This is done, right? Fine. So this constructor is usually used, now please look here guys, to refer to the class variables. This variable scope is within the class. Okay, maybe I need to address that very soon. So this is within this class. What's the name of the class? Addition. Fine. So what are the variables now? We have seen A and B. Fine. So we know that this constructor, right, takes 2 arguments. Now we know the init is a special type of method called as a constructor, which is automatically called whenever we create new objects for the class, no doubt. And this one now refers to the what is used when we want to kind of set up our class variables. And in this case now we have seen it takes. Now you might say 3 arguments, but you are saying 2. Please listen. Leave self alone. Look at this. 1 do, 0 do. So these 2 arguments are there. Okay. And this we use to assign values to A and B. No worries. Now, let's look at self then. Init over, this over, that over. Let's look at self. So what does self do actually? Okay. So this self is usually the first argument. Look here. It's not a variable now. It's the first argument, as you can see it here. This self is a first argument. What does it do actually? What does it do? So It tells you that, see, listen, please listen. The purpose of using this self is to distinguish your class variables, okay, and methods from other functions in the program. Please listen. This refers to the class variables. Agreed. So I have to use self, should I call it statement to access it. And this happens only when we are using the concept of classes, which is a subset of, which is what we are studying in object orientation, okay? Trying to wrap this around so that the scope will be limited within what you have to talk about. Listen, I'm not talking about access specifiers now, public, private, and protected. No. Whenever you see this self dot whatever, it is actually referring to this class. And I use this kind of as maybe a discriminator to distinguish my class variable from other variables and functions in my program. All right, keep this aside. Once we are done with this now, okay, we now go down and say, okay, fine. What is this actually now? What is this C doing here, right? What is this C doing there? So we need to create an object of the class, yes or no? So this C, like in Java, we say whatever obj equals new, whatever obj, whatever class name, whatever. But please let's not confuse Java with Python. Let's stay with Python. So this was now what this refers to the object of this class. And why do we need this actually? We want to use this now, right? Okay. We want to use this now to see the values are there. What should we return? When we call addition, so we need to add these two, right? 3 plus 2, and we should get 5. Hence, an object is needed. No worries. Now, if this holds true, okay, let's try to use this maybe to perform some real case study. Okay, so this is done. Let's look at a classical example. So we go to example 2 and we implement that very soon. Example 2, we take a more practical example. We run this, no worries. Guys, do you remember I pushed this to my GitHub repo yesterday? Please, every code is there also, okay? Every code is there, including the annotated note also. Feel free to go through them and get back with your doubts. Okay. So let's say we have studied the concepts of, we've studied the concepts of strings and punctuations. And now I thought, okay, fine, can I actually look at a word? Please listen. Look at a list of words, okay? And now try to check how many of the words start with. We've done this example, yes or no? Okay, I better write and then explain. Which one starts with? Which one ends with? You have seen that, right? Which one contains exactly 2 letters, okay? And then we now need to print them out using object orientation. We've done that example previously. I don't know, maybe on day 7 or day 8, I can't remember. All right? So what do? That means that if you are given a word, so let's say, what do we want to do now? For instance, okay, example, a more practical guide. For instance, I have this, this is who I am, okay? Now, this is a word, a sentence actually. Now, what I want to do is, I want to print out what I expected. Expectation is this. I want you to count number of words here, number of words in this string. I can take it as a list, no worries. Number of words here, first case. How many of them are exactly 2 words? 2 characters, please. Number of words, 1, 2, 3, 4, 5. No doubt. So this should return what? Returns 5. Now, exactly. That means words with exactly 2 characters. How many are there? This returns this guy and this guy, only 2. Fine. Now, which one starts with T? Starts with T. Okay. And what I want you to do is you should extend this to a file. Save this in a file, load this, and perform similar operation on that. Starts with T. Maybe ends with M. If it starts with T, only 1. Ends with M, only 1. Right? Again, which is AM. Fine. So then let me say we're going to have some stuff. So how will you actually implement this program, guys? How do we implement this program? That means for us to implement this, we need to do one thing now. Please listen. Couple of things here. We need to read this as a list or whatever and convert this into what? Lower cases. Yes or no? First, splitting will be done. Splitting will be done. Okay, say some hints. Hints. After you read, okay, or take in whatever, input whatever the text. The text. In this case, it is a sentence. What do? You're going to replace, please listen. If you have any punctuation, let's say it's like this, it's. If you have any punctuation, you can actually replace all punctuations with what? Replace all punctuations with empty string. We've seen that before. With what? Empty string. So if we're going to replace it with empty string, that means we need this, right? Then we need to import what? Punctuations. Yes or no? From string library, import punctuations. So this I did not add it as a step. So the first step is this, second step is that. If after that now, we now need to do what now? Before we start comparing, some cleaning we did, right? We converted all to what? Lowercase. Convert all to lowercase. All to lowercase. No worries. So after we've converted to lowercase now, then we split it and call split method. Please don't worry, don't take notes, just pay attention, okay? Then we have done all the pre-processing. Yes or no, guys? This aspect is what we do when we start, it is a must, when we start building our machine learning pipelines or model, or when we start working with maybe like doing some data science projects, data science and ML projects. So these steps are called data pre-processing, because we want to ensure that whatever we are going to load is in what? Well-defined format. So this step is done. Now we start creating the methods that will handle everything. Remember, so we now go and create a method to do what? Read the words, create method. So I can go to the fourth step now. Create respective methods. Create respective. Okay, I call it methods now, functions. So you can call them function with starts with, example starts with, ends with, okay, maybe with what, whose length is blah blah blah, okay. And after that you print. Last step, print the result. That's it. Hashtag. So if I were you, you can also try to write the algorithm for this in form of a pseudocode. Well, that's what we've written, or you do a flowchart for this. That is at your leisure, okay? Then we look at the program, okay? So yes, I think, and after this now, we look at next thing. I'm going to explain quickly, and then we start writing the code. So let's look at the concept of inheritance. Concept of what? Inheritance. Very simple. I believe everybody knows this. Everybody knows this. Let me use myself as an example. What is my name? Who knows? I am Victor. I have a middle name. I have a surname. Don't try pronouncing it. In between, if you want to know where I come from, there are two names that are missing. I will not give that out, okay? So, two names are there. Now, this is my qualifier. This is my family name. You saw the concept of ancestors yesterday? Fine. So this, on no account should I drop this name. This one I can decide to change. These two I can decide to change. Why am I telling this now? Sir, what is this? Inheritance. This is my ancestor's name. That means it is inherited from my forefathers. Forefathers. I remember when growing up, when my dad said forefathers, I thought there are four of them. F-O-U-R. Okay, guys. If they are not forefathers, they are forefathers. F-O-R-E. Fine. So if that is the case, please listen. Can you say Victor is the son of Aguasi? Yes or no? Yes. But these are like some generations before my dad. So if I want to trace it, I'll say Victor Please listen. Please listen. Has some traces from his father. His father has some traces from his grandfather. Grandfather has some traces from great-grandfather. That has some traces from another one. Maybe I'll stop here. I don't know who is Agwasi actually. So why did I use this? There are concepts now you need to understand. This is the superclass. It is the great-grandfather by ya. Okay, we cannot say for ancestors by ya, no way. So this is the great grandpa. No worries. Grandfather, father, sorry. Grandpa, grandpa, father, and son. So we go to the son. The son is the base class. Sorry, superclass is also known as, this is child class, please. Child class. I think superclass is known as base class. I don't want to confuse us. I think superclass is known as base class and then this is known as child class. I don't know. You got the concept? From here, the threads gets passed down to this. That means that things I'm doing is that this guy inherited some traits. Inherited traits, T-R-E-I-T-S, from his dad, who inherited traits, right? T-R-A-I-T-S, some genes from another one that inherited another one. So we got the concept, very simple. So if you look at it clearly, we now say, let's use other abstract examples. Let's look at car. Car is the big guy. What are the subtypes of car? Maruti is a model of car. Maruti is a model of car. Let's say Maruti Suzuki is another one. In this Suzuki, you have another one, maybe Alto 800, whatever. So this is the super, this is child, this is grandchild, that is whatever, great-grandchild. That's not what I meant. What I mean is this is the base or superclass and these are all the children classes. So having said that now, what did you notice here? That the properties of the parent, let's say this is the parent, can be extended in the child. Yes or no? Because when Maruti Suzuki manufactured Maruti Suzuki, maybe Alto 800, they have manufactured another one actually. There will be variants of Maruti Suzuki, right? So you have other ones which has maybe like Alto 900, I'm not sure, Alto 1000, I'm not sure, okay? So leave that. So the child has the privilege to extend whatever the parent has done. So let's create one in Python and then we go and run programs quickly now. So how do you implement inheritance? Same thing, class. You call it what it is now, parents, no doubt. Hold on. Now you know the concept of init method now, so I'm not going to define it again. So def. Now I'm going to use this. It's a special what? Method, a special constructor, and you know by default it's going to take self. Since I only want to inherit one property, I call it A. Fine. Now I return that. I'll say self dot A is equal to A. No worries. Define another method. This is for parent, okay? Now we say method 1. Okay? Then it takes in what? Self. No worries. Now, in this, I'm going to say return. Please listen. Say self dot, maybe I'm going to take a number and implement this using the concept of inheritance. Please listen. This number, maybe I'll raise it to power 2. Okay? So if I'm doing this, actually, I have to use a number. For now, let me use a string for now so that you will see some stuff. Say a dot a star 2. Double it. No worries. Now, maybe I want to create another method. This is still in the parent. So for now, I will stop here. Let's go and create the what? The child class. So parent class Hogi, child class Bantu, child Okay, sorry. Child, I should say class child. I'm saying child class. Fine. Class, please maintain the indentation. Okay, class child. This class child is going to extend whatever is there in the parent. Yes or no? Colon. In Java, we say extends. You have to use the keyword extend to implement inheritance. Okay, so that is Java for you. And then we define some stuff here. Methods. So first one, we need our constructor. No worries. Init, fine. Taking self. Now, in this case, I'm going to extend the properties of this parent. So I'm adding another attribute. In this case now, another what? Integer, whatever, or whatever, another variable called b. Done. I'll say now, since I added that, I'm going to call two of them. Okay, I'll say self dot a is equal to a, no worries, and then self dot b is equal to b, no worries. Fine. Now, after this is done, what I'm going to do, I have to create now the method because these are my constructor. So I'll create a method now. I'll say def method 1 and I will stop here. Method 1. Guys, if you notice sometimes, like I prefer to write. The reason I'm writing is not because I want to waste your time, but I want you to be involved in whatever I'm doing. Try to debug this along with me and check whether I have gone off point. That's the reason I try to write this down. Fine. Okay. So this is first method. Okay. And then this is going to return something. Now this returned into 2. I said child can actually extend whatever is in the parent. Yes or no? So I'm going to say self dot what? A maybe into 7 or 5. Anything. Now I will now have another method. Okay. Maybe I create another couple of methods, maybe say which will return A and B. So maybe the child now is greedy. The child says, see, I need other features. No, you know, I'm a new generation baby, so I need to implement more features. So no worries, fine. Dad says, okay, go ahead, beta. He says, okay, fine, I will do that. Thank you, Appa, over. Now, here I'm going to say what now? I want to say self, I want to add some stuff. Dot A, okay, plus maybe like I say self dot B. Now we are done. What do we need now? An object. Guys, don't forget. Once we are done, look here. We now need to create what? An function and whatever some stuff. We need to create an object for this, right? Look here, guys. Opawala. Okay. So we create an object that we used to call this guy. Fine. Remember this first example, right? That's what I was referring to. Look at this C, the object. So we can use the same object, no worries. Fine. And now we need, you can actually, the question is, can I use one object or should I use two objects? Yes or no? So try now to distinguish child from parent by creating two objects. Yes, you can use one object also to call them, no worries. But to avoid confusion, okay, try to create two objects. Now create the objects for them. So I better use parent and child as what? The objects. So I'll say br equals what? Parent. And parent is going to say hello from parent. Okay, hello from parent. Now the child is going to say hi, hi, pa. Like this is the child. Fine. He's going to say hi, dad, whatever. Okay, dad. Okay. Okay, yeah, welcome. Why? Because we want to implement this as well. Yes or no? Now, so then I cover this. Now I'm going to print some message now and call those methods. I have created an object. Now I need to call the methods, right? Call the methods. How do I call the method? Using the object of the class, no? Fine. I have created PR and CH. Excuse me. So you can say now, okay, PR dot method 1. Only one method 1 was there, right? For the parents. Yes or no? Only one method we created for the parent. But for the child, we created two methods, method 1 and method 2. Now, and then we go again and say CH. Okay, so you can actually use this. Please listen. You can use this also to call the child, no doubt. So PR dot method 2 and see whether there will be an error. Can a parent call a child? Please try this. We will try this. Let's child call the parent. Yes or no? Because the inheritance says the subclass or the small class should extend the properties of the superclass and not the superclass extending the property of the subclass. So we try this and see whether error will come. After this, now we say the child, okay, dot method 1. Obviously, nothing will appear. We have to wrap it around print statement, and then this dot method 2. Okay, so you can put some print statements here, okay, something like that, or you call them from the console, or you wrap it around print statements. That's all. Okay, so you say print over. Now let's run this. Okay, hope you understood the concept of inheritance. Hope you understood why we need that. We started from object orientation, object-oriented programming. We understood what we mean by an object, what is a class, and why we need that. An explanation of all these keywords and some stuff, because applications we are developing will be bent on all this. All right. So this is done. Let's start running this program. All right. So I'm going to maximize this one screen at a time. So this is what we plan doing. So there is actually a loyalty program, and I'm going to extend this class. Okay. I will extend the class so that we understand. We tried looking into this program. Okay. Now, let's start from here. So the first one says here, please listen. Please listen. This is a simple example. Okay. So this is what we've seen, right? And we return this. So we need to add this. So what did we do? Created the class using the class keyword. Yes or no? Fine. Okay. Now every error will come now. I need to comment this guy out. Fine. So we created the class keyword, and then the class name. Use our clock constructor to initiate that. Fine. And remember that this refers to what? Internally, that this refers to the class variables. Then we return them here by performing addition, and then creating an object for that, and then we call this. And just printed this. So you can actually print the sum of something like this. Say the sum is this dot, okay, comma, this dot add. So since we are going to use print, okay, that is close, fine. Okay, F5. Now, see the sum is 24. Got it? So this looked longer, but we actually did that using, let me zoom this in. We just did that using what? The concept of classes. Fine. Done. So comment this guy out. Let's forge ahead. Next one. So this closed here. I'm going to close this guy here. Fine. Okay, next is a real example. Okay. So please listen. This real example was what I tried explaining. Let's start from the reverse. This is a more practical example of OOP. This is a string. In this string, now what am I checking? I want to check what? Number of words. Number of words that starts with T. Number of 4-letter words. Number of words that end with that. You have to implement all the methods. No worries. How many words are here in this sentence? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. We should expect to see 8 here. Clear the console first. Go up. Let's start. I call this sanity check. Why did I import punctuation? Because I'm going to use it, right? So go through all the elements that are, all the items that are in my word, obviously in my string, which I can call a list now, no worries. Wherever I see anything, okay, break apart, and just any of the punctuation. Actually, there are no punctuations here. Yes, it is there in the last one. Okay, replace with what? An empty string here. Okay. Now, convert everything to lowercase and then split them. Pre-cleaning is done, sanity check. So, which is similar to my pre-processing. Pre-processing done. Pre-processing done. Processing over. Next, number of words in that, right? Len. That's all. That starts with what? S. Yes or no? Using what? List comprehension. Using list comprehension, how many of them learn of that which starts with S? Number of words whose length is N is what I'm going to give at runtime using this comprehension. So, whose length is 4 at runtime. Let's run this. You can put it here. You got my point, right? Length exactly equal to 4. No worries. Fine. So, you can check now len equals to 4, 1, 2. That's it. If you make this oops, it will be included there also. For now, let's run this. F5. Now, this returns it like I said. This was a string, but it's going to return it as a list. So it's good if I call it a list. Now, this is a more practical way of oop. Did you see that is gone? Exclamation mark is gone because it is a punctuation. Sanity check done. Once this is done, number of words to check, 8. We saw that. 1, 2, 3, 4, 5, 6, 7, 8. We start with T. Let's go back there. Only one starts with T, this. And it has been converted to lowercase. Later, which words is 2? Fine. So you can increase this. Hope this is clear. All right. So let's continue. I'm going to remove this from here. Now, increase this, and this is closed there. No worries. Now, inheritance. Okay. So let me close this here. Fine. All right. Yeah. Okay. So let's look at inheritance. So we've understood the brain behind inheritance. We've seen how everything works. Sorry, Lavish Lens, I think I thought you have a question, then you left that again. Okay, so let's continue. This is the parent. Fine. He says, I'm going to take what I don't know. You have to supply me that, and I'm going to multiply it by 3. Also, I'm going to take whatever I don't know is a string. I'm going to add punctuations to it. Child says, okay, Appa, if you're adding by 3, you know, you only have 3 lakh rupees. I'm going to take that and increase it to 9 lakh rupees. And instead of you adding some stuff here, I'm also going to take these 2. Please listen, please listen. The parent will have only these 2. If I say hello, it will print hello, hello, hello. And then it will print hello with 3 exclamation marks. Then the child says, why will I print hello only 3 times? I'm going to print hello 9 times. And I'm also going to add this. Listen, hello to with hi, and I'm going to add that. Hence, in my child, I'm going to see this, okay, and 9 times, okay, and I'm going to see this one. So parent implemented 2 methods, child also implemented 2 methods, but child modified this one. All right, so let's run this now. So what is it? Object is being created. Hey, for that, child says, yo, bro, you cannot say this. It's an insult. And you cannot say yo, dad. You can say yes, dad, not yo, dad. If dad can say hey, you can say okay, yes, dad. I said day. All right, dad. This is fine. Now we call this. We got the point for the parent and then for the child. Use this to separate them and empty blank whatever blank. What's it called? White space to separate them. Just like blank space. No worries. Let's run this. Now, I think I should clear the console for now. And I think I should increase this. Let's see. Okay. So I'm going to run this now. Fine. So you see, look at the output here. Parent method 1. Hey, hey, hey. We got the point. Yes, 3 times. No worries. Okay. Now, and then the method 2. Hey. Oh, come here. Child says, yes, 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 yes. The child is angry 9 times. Then child says, okay, fine. I'm going to implement this also. Yes. And then I'm going to say, yes, dad. This was never implemented in the child class. Yes or no? But we only inherited it from the parents. It looks like we have 3 methods here, but we had only 2. Okay. So what I want you to do is this. Let's try now assessing which method 3 from the parent class. You got the point? So what I will do here now, I will say this parent now, we try to assess method 3. Let's see what happens. Okay. F5. Now you see here. Because, see here, parent has no attribute method 3, obviously. A parent obviously cannot extend. It's like ultra. Child only should extend. So that was what I was trying to explain there. Okay. Fine. Now, done. Okay. Okay, so any questions so far, guys? Clear. Any questions so far? All right. So we have to introduce the concept of game playing. Okay. Because that is a kind of a fully qualified assignment which you have to do. I will start the game. I want you to complete it, and we will continue tomorrow with a couple of games also. Thank you guys for cheating. You only joined for attendance. Number of viewers has just increased. Fine. All right. So This is done. Okay, so what I actually did here, please listen, guys. Here I said also we can extend this before we go into gameplay. Pay attention here. We can actually extend this. So I said here, add some new methods to the child class. Parent, no worries, right? The value of these class variables are no worries. Now, for the child, it says, hey, I also want to include whatever is in the parent class, and then I have to call the same thing. Okay. So I release this now, and I'm going to call this 3 times instead of calling it twice. So that's all we did here. Okay. That's all. Now, so you see here, it's called thrice. So I'm going to drag this up so that you see what I'm doing. Okay. So parent method, hey, this is fine. Then child also call this couple of times. How many times did I call now? Same 9 times. Sorry, that was why it increased. Okay, 9 times. And then again say this, and then the other method says here. You got the point? Fine. Because it has to return this from that, right? And this was actually coming from the parent only. Fine. That's why we have these 3 methods. So you can actually, as a child, extend methods also, which will invariably extend all the attributes and properties of the parent class. Now, based on all these things now, can we design a game playing stuff? So I'm going to run this game, then we will try it, and then I will encounter an error. Then you understand why we need to handle exceptions. So before this game playing, I need to talk about exception handling. I'm not going to implement it. I'll just tell you exception handling. Okay. So I'll close this for now. Let me see any error. Okay, Anjali now is telling something. Okay, so exception handling. Let's look at an example. So I'm going to run in the console as you are seeing here. Let's say we want to do this. Say 0 divided by 4. 6. 0 divided by 6. I don't know why people are typing I now. Okay, maybe 0 divided by 6. 0. Good. 6 divided by 0. What is the problem? 0 only, no? Don't tell it 0. 6 divided by 0 is what? Okay, I listened to a webinar, okay, where I don't want to laugh at him. He's a very good professor from IIT. He's calling it 0 divided by 0. So guys, permit me to copy him. 6 divided by 0. What is the output? 0 or error? Okay, the output is error. Now, this is called division by 0 exception. Okay, so the thing here is you should be able to know when somebody does this. This is 1, division by 0 exception. Now, let's say 6. Listen, guys. 6 divided by a variable. Say 6 is a value divided by a variable a. Good, good. So 6 divided by a. Listen, what is this now? A is not defined. You cannot divide a value by a variable. You can also never divide a variable by a value. So these are 2 cases. Let's say a divided by 6. So when you encounter this, I don't want my program to quit. I want it to handle this and continue. Okay? So because of this now, we need to look at exception. Let me run this code now, and then we try to say I don't know what to do. Okay? I don't know what to do in this code, but before we explain this code, it's very lengthy. So let me run the code now. Okay? So this is tic-tac-toe. Fine. I believe you know how to play the game. Let's run this now. It says enter spot for player 1. All right. So what I'm going to do is I will just say 6. Please listen. I'll say 2. Okay. Now look here. Python was asked to do an operation with an object which doesn't support it. Did you expect a type? Redefining the name R from the scope in this. Error band 2. Okay. Cannot unpack an iterable into integer. Please listen. So this the program has terminated because of wrong input. Let me run this again. Okay. And then we enter, say maybe I enter 1, comma. See, you did not tell me what to enter, right? 1, comma, 1, comma, maybe 1. I don't know what to enter. Now, it says here again, okay? Too many values to unpack. Expected to. We don't want this to happen. Try and accept zero division. Absolutely, Jeshri. No worries. No worries. We'll come to that. Okay. So what I'm trying to show you is why we need this. Okay. So yeah, yes, I can say is a keyword in this case, obviously. Okay. So I will clear it. Sorry. Oh my God. So I can clear this now. So because of that, you should tell the user what to enter. Okay. And what to expect in this. So enter a spot for okay player one. Okay, say I say 1 comma 1, enter. Now it has marked that spot, right? Okay, enter spot for who's player 2. Maybe he says I don't know, maybe I don't know what to enter 1 comma maybe whatever, I don't know, 2 something, I don't know. Okay, he has marked this side. So we keep doing this until this is over. Okay, now let's look at how you build this game. Okay, you should understand the logic behind this before you start creating. And please listen, let's look at this game now and let me see if there's anything you did not understand here. Let's start from the beginning, guys. Let's start from the beginning. A class, constructor, a list, first player. Check the spots that are open. Use list word comprehension. Move through this two-dimensional list. For items in rows and columns, in the range of 3, we know, right? I told you this before. 3 rows, 3 columns. If you increase this now, say 4, you're going to get index out of bound exception. Fine? Range of this for rows and range of this for column. No worries. Initially, let 0 be assigned there. Check for valid moves. If it's true, perform this. Otherwise, return false. Make a move. If the move is valid, ensure that whatever you get is what? There is no remainder. Divide this, okay, by 2, shouldn't give a remainder, and increase and add 1 to it to increase the move. Check for the winner. Is there anything, please listen, we have not touched? Look here. Look here. Because we are reading a two-dimensional list, fine? For each of the positions, 0, 0, 0, 1, 1, 0, 1, 1, like that, okay? 2, 0, 3, 1, 3, 0. After that, print the winner. Initially, these are the characters that we use to mark them. Move through them in rows and in columns. Check the characters that are at each location and print them on one line. We don't want to go to a new line. After that one line is done, say first row is done, second, put this space, okay, second one, space, then third one. And now, with this, you now say, okay, fine, check. Whoever wins, look here. If at the end of the day, okay, all ended with zeros or whatever, we say is a draw. Otherwise, you say player, which one, first player or second player, wins. There are no exceptions handled here. So this code will be modified to handle the exception, okay? Such that when I do some stuff, okay, then you'll be able to understand where exactly I have to include that. So let's look at the logic for playing this game. All right. So let's look at the logic for playing the game. So I'll minimize this now. And let's look at a game playing logic. Game development. So why did I tell you this? Because if you remember from when we started, let me go back to how we started. We said we are going to build some what kind of projects we can build. Okay. Maybe tomorrow we start looking into this. Oh, my mouse is disappearing. I cannot see it here. Okay. Okay. Look here. This current quiz generation, whatever, and company name generator, treasure hunt application, rock, paper, scissors, password, whatever generator, mysterious maze, and then vending machine till here. So these are tentative projects. Okay. So we're going to build maybe more than 10 of them actually. Sorry guys, I cannot find my mouse. Okay, fine. I will minimize this, get back here. All right. So what is the logic? So we have seen the method. So I'm going to explain few what those methods are doing. So game development using OOP concept, using OOPS concept. Let's look at the logic. A case study of what? Of tic-tac-toe. Okay, tic-tac-toe. So the first thing is, what are the rules? What are the rules? Okay, so for some, yes, you don't know what it is, so you go and ask Google. Google, what are tic-tac-toe rules? Tic-tac-toe game rules. Fine. Now it says it's called a north and crosses or X's and zeros. It's a paper and pencil game of two players. Okay, it should be played with two who take turns marking the spaces in the tree by what? Sorry, marking the spaces in the 3 by 3 grid with X or 0. No worries. If we are going to mark it, the player who succeeds in placing the three of their marks in horizontal, vertical, or diagonal row is a winner. So you can try playing something online. And after this, we try to create this using ThinkTab. So if I see example, if I continuously place here, see, he knows I'm going to make this move. So he has to come check this and move this. Now let me try placing, I try this, he's going to place there. Wow. Okay, let me place here, he's going to place there. Wow. Now, that is not, this is a draw. You got the point now. Fine, this is a draw. So you can actually, you got the concept. So we have to check horizontally, check vertically, and check diagonally. Similar to my Sudoku, right? Okay. I don't know if it is Sudoku anyway, but fine. Very simple. So if you've seen the rules, yes, Google helped us. Google helped us. Google, thanks. Thanks to Google. Or we say thank you. It helps us understand this now. That means we have to think of what now? What are the more functions now? What are the functions we need? Functions needed to prototype this, the game. So if this is the case now, we now need to say, okay, fine. Let's say we need to find, first of all, find open positions. Yes or no? So step one, check for open positions. Before we start marking, right? All right. So check open position. Check open spots or position. So this is a method. Now this method should do what now? What should we expect this to return? It should yield, should return what? Lists is a list of what? Places that have not been marked, right? Positions that have not been selected. Being selected. All right. So this is done. Let's check for the next one. Step 2. Says what now? Check for valid move. Yes or no? As you saw, when we tried doing that, that fellow said, oh, you want to move that side? I'm going to block you. Check valid move. Valid underscore move. So which move should be valid? Horizontally, diagonally, or vertically? Fine. So what should it return now? So this will return now what? Should return what? True, right? If what? Move is allowed. Yes or no? This move can either be horizontally, vertically, or diagonally. Or false otherwise. Else what? False. Agreed? Done. If that move is valid, then you make a move. Make a move. If move is valid, make a move. Make a move. Now, so this move has to be only in the valid direction. No worries. Okay. So only in the valid direction. It cannot go in the invalid direction. Now, if you do this, you have to repeat this. Repeat until condition which applies. What's the condition? Draw or winner. Then you have to check for the winner. If it wins, done. Otherwise, it's a draw. There is no one who loses in this game. Yes or no? We saw that now, right? So in this case now, we say check winner. Winner is the person, yes, who places his own first. Yes or no? We've seen that. So, but first to place before the other. First to place before the opponent. Before the opponent. Else, draw. Game drawn. Fine. Done. So let's now understand, okay, how we do this in the next class, which is tomorrow. All right. So before we wind up, I'm looking at questions. Do you have any questions, guys? Are you able to follow? Did I try confusing you in between? Did I do justice to what we planned today? Let's go back and say this, okay? So object orientation or oriented programming, done. Creating your own classes, done. Essence of inheritance, done. Mini projects, we've seen example with mini project, which is this guy, tic-tac-toe, okay? And then we are going to look at other programs by tomorrow, done. And what is your homework? Homework is try on your own to see if you can come up with the logic of the tic-tac-toe. And I'm going to push this out now also to the repo. You download it, go through it, implement this, and try to handle exception. So implement and handle exception. I'm pushing that out as soon as this class is over. Implement and handle exception. Only put your try and catch block. That's it. Try, yes. Like Jayashri said, so you cannot get try and catch here. Try and accept, okay, fine. Zero division, exception. That is in the other case. But in this case now, we have to check all the possibilities, okay? So I think I did not show you the possibility in this case, sorry. So look at the possibility, something that might happen when you run this program. Say, I think I showed that, but let's see. When I run this now, and I don't know what to insert, okay? Say, yes, I did that actually. So maybe I inserted A. Yes, so it says here, A is not defined, obviously, okay? So it should not break abruptly like this. It should say, sorry, we expected this. Then it should give us that error message that we don't need this, we only need you to enter positions this cross that. Got it? Fine. So on this note, and in the absence of any further questions or further clarifications, I want to thank you guys for coming in, for checking on us today. And please don't just come and cheat us here by only taking attendance and going. All right? So, and in case if you have any doubts, guys, I'm always open. You feel free to get in touch. And tomorrow, please don't forget, tomorrow's session is 10 to 11. I hope that is clear to everyone. So we wind up tomorrow's session, Saturday, 10 to 11 a.m. We try to look into exception handling, and some more projects. Thank you, Amit. More projects. And I should see your GitHub repo, guys. GitHub repo. So, sir, you said you are going to take a form, create a form to collect it. Exactly what I'm saying. But at least when I see people who commit to the stuff and then clones the stuff, or you kind of fork it FORK, no problem. I want to see those things on my GitHub repo. Then I will know whoever that has done that. Okay, very simple. So this is what we do tomorrow. And then, yes, and maybe by Monday, you see we are learning so much in less time. Thank you, guys. Till I come your way, happy studying. And please don't enjoy your weekend and forget we have tomorrow's class at 9 to 10. Bye for now. Have a blessed weekend. Bye.